Sitecore in North America. I don't want to go back to my Commodore 64 and TRS-80 days, but I got my start in information technology doing electronic data interchange for a silicon company in the Valley. And before joining Sitecore in 2004, I worked on a number of web CMS implementations, about 20 in a variety of industries, including Network Associates in Symantec and US Bank and John Deere and Intel, which is probably the one I was happiest with. Now I work as a consulting product architect on projects including Sitecore Azure, new releases of OMS and CMS. Today I'm going to speak about some of the technical aspects of Sitecore's soon-to-be released, or really released today in technology preview form, Customer Engagement Platform, or CEP. CEP expands on what was formerly known as OMS, Sitecore's online marketing system suite. I'm going to be confusing suite and system for the rest of the day, which has always provided more than simple web analytics. This will be a fairly technical presentation, so anybody who doesn't want to see database schemas and code and things like that might want to switch to a different track. As always, feel free to blog or tweet about anything you see or hear here at #Dreamcore. You're welcome to contact me directly, such as to request the slides, which will be available after the presentation, and the last slide will include my contact information. If you have any questions, let's save them for the session at the end of the presentation. Maybe we can see if any questions come up on #Dreamcore. Howie will be monitoring for questions from the audience and from the web. Just out of curiosity, how many people attended Dreamcore last year? So it looks like a little bit over half to me. And how many people saw the 10 things you didn't know you could do with Sitecore presentation that I gave? So just a little bit less. Went really well in the US, didn't go so well in Europe. And I should warn you today that I'm not going to have any live demos. I learned from that European experience not to try that. Lars had the brave approach of doing the live demos. So I would like to thank everybody that rated that session highly. That's really good feedback. I've been doing a lot of work to build this community during my time in Sitecore, and I don't get that kind of response very often, so I really appreciate that. I think I'll probably win the prize again for having the blandest PowerPoint deck in the entire conference. So I'll just warn you. I'm not a PowerPoint person. I will show some code examples that are going to be in pretty small fonts, so if you're not near a screen or near the front of the room, you might want to move forward a little bit. It's not going to be in Visual Studio, it's just slides. So with that, we'll get started, hopefully. So before I get started, I do want to ask some questions of the audience regarding OMS 1. I would assume that most of the people here are Sitecore developers, but can we just get an idea of how many people would consider themselves to be Sitecore developers here? So yeah, it is almost the entire room. How many of you have customized OMS reports? Very few people, just 2 or 3, maybe 5, 7 people. How many of you have invoked OMS APIs? Oh wow, that's actually a significant number. How many of you have written SQL queries against the OMS tables? So about the same number as APIs. And would anybody consider themselves to be an OMS developer? We got a few, that's great. Hopefully by this conference next year, we'll have greater numbers on those kinds of questions, because the new version of what we used to call OMS has a lot in store for developers and organizations using it. So this slide lists my agenda for the remainder of the presentation. My goal is to present some general information about the customer engagement platform. Some of this will be a repeat of what has already been said, but I'll try to keep that as minimal as possible. The design objectives, so what engineering and architecture was after with this release of the customer engagement platform. The new strategy for managing database operations and interactions with the database during analytics collection, which improves performance. We'll take a quick look at the CEP database schema. Some of this material is included just so that you have it for reference after the presentation. I really don't have time to dig into the schema very deeply, but I will provide that diagram for anybody that wants the materials. We'll look at a couple of CEP configuration settings. Some of this presentation is going to make CEP look bigger and more complicated than it is, and when you see the settings and some of the pipeline stuff, you'll realize that it's not quite as intimidating as it might look at first. And lastly, I'll look at some of the new pipelines and features in the CEP API. Not everything that I talk about today will exactly match the technology preview released today, which may not be feature complete. And I developed these slides over the last couple of months, so just as a warning, not everything will be completely accurate, but all of the features features that I described will be in the release on June 7th. It's currently scheduled for June 7th. So before I can really introduce the customer engagement platform, I have to introduce the digital marketing system, or DMS. With this release of CMS 6.5, Sitecore will rename the OMS from the online marketing suite to the digital marketing system, or DMS. DMS is basically what would have been OMS 2, including marketing automation and improved personalization. The digital marketing system also provides automated traffic classification, so identifying traffic that comes from search engines and RSS readers and email links and things like that. But most importantly, from my perspective, DMS lets you analyze efficiency instead of just traffic by associating a value with each page event. And I'll come back and explain what that means later, but this is really one of our differentiating factors right now, is that we can find the most efficient paths through your website and the highest value paths and customer prospects, things like that. So that's the DMS. Again, it's a replacement for OMS and it's functionally equivalent to OMS 2. The Customer Engagement Platform, or CEP, is a term that indicates the CMS product with the DMS product installed and may include additional components like web forms for marketers or email campaign manager. So DMS replaces OMS and CEP is the CMS platform with the DMS product installed and may include additional components. So I work with these things as one unit. I'm not exactly sure where CMS ends and DMS begins. So I typically use the term CEP, except when I think it's important to differentiate something that is specific to CMS from something that's specific to DMS. I also think it will continue to be acceptable to use the term OMS for some time. There probably will be some Sitecore people that don't want to hear that, but we've got that name out there in the market, and so we need to be able to respond to it as if people were talking about what we now call DMS. I'll also use the term analytics without the word engagement, because when I'm talking to people that understand web analytics but have never heard of what we offer, it's just easier to create a frame of reference by using a term, and it also simplifies some sentence structures. So this slide lists some of engineering's key objectives for the customer engagement platform. We had some discussion from Carrie about the marketing automation, and Lars running around here. So Sitecore now provides engagement plans for site visitors, which function much like workflow, except instead of putting a content item through a process, you're putting one of your visitors to your website, or maybe a record from your CRM through a process flow that interacts with that user. So you can use engagement plans, for example, different campaigns can trigger different plans. So if a user comes in through one campaign, you can kick off one engagement process, or if they come in through some other forum, you can kick off a different process. And you can do things like sending introductory emails and follow-up emails. Really anything that you can do with .NET, just like workflow. So if there's some functionality that you need that's not out of the box, you can always just have our engine call that functionality. And you can also treat visitors differently based on attributes of their visits, such as whether they use search terms to get to your site, or what the value of that, or what the perceived value of that prospect is. The customer engagement platform also improves capabilities for real-time personalization of both content management and presentation. So showing different users different data and presenting that data differently based on their profile. In the segment of this presentation about APIs, we'll see some improved APIs available for accessing GeoIP information. And so that is helpful for providing real-time personalization to your users, even on the first request for an IP address when you don't actually know or you haven't previously looked up that IP address from your GeoIP provider without really hindering performance. So we'll see how that works. CEP also uses the rules engine, which is one of my favorite new aspects of Sitecore. It actually has been out for a while, but we're really seeing it get adopted more. So that we'll use that for personalization within the DMS product. One of the most valuable new features of CEP, as I also already mentioned, helps you analyze efficiency instead of just traffic. And that's basically by associating value with different things on the page. So instead of saying we had 40 users click on this page, you can assign a value to that page and then rank your users by value, rank your paths for your site by value, and things like that. You can put a high value on events such as subscribing to an email list, requesting an evaluation of the product, or registering for a conference. This presentation describes changes to the CEP database architecture, as well as the strategy for interacting with that database. And the goal there is to improve performance, which will hence lead to greater scalability and greater traffic coverage. So a lot of this release is about performance. CEP provides automatic visitor classification, identifying visits that result from organic search, branded search, email links, RSS readers, and other channels as they come to your website, or the different entry points from which they come. And one of the other major objectives of CEP is to improve report readability, and we've added some new dashboards, such as the Executive Insight Dashboard. So next I will present a diagram of the customer engagement platform architecture. This is the same diagram that Carrie and Lars presented, but I'll go into a little bit of detail. Again, it's going to look intimidating at first, and this is here for reference or after you leave the conference. So I will walk a little bit through the diagram, but I don't want to spend too much time here. CEP is significantly more complex than OMS, partly due to scalability enhancements. And so we'll see things like a separate analytics and collection reporting database, which are optional. So you can merge those databases if you want to. But really the diagram just looks intimidating at first. It's really easy to understand once you kind of figure out how to interpret the diagram. So the slide I'm going to show makes it look like there's a number of systems involved, a number of servers or instances of Sitecore. But you can do all of this still on your laptop. So you can do content management, content delivery, analytics collection, analytics reporting, and automation, and host the SQL Server all on your workstation still. So this is, again, kind of a conceptual diagram. So this diagram, this is the functional and data elements of the customer engagement platform. The blue box on the left represents the content delivery environment, or the functions in the content delivery environment. And these include things that you're showing to your customers, your visitors to your website. So that includes multivariate testing, rendering rules, automations, capturing of analytics data, and notifications to your visitors, such as sending email messages. The pinkish box on the right represents the content management environment, or the functions in that environment, and that includes typical content management, such as data entry, workflow, engagement automation management, so defining your engagement plans, and reporting, so retrieving data from the DMS. The green boxes in between represent databases, and so at the top we see the content management environment interacting with the master database, which contains all the versions of all the content. Also at the top, you see that content publishing to the content delivery database or the web target. But we also see new databases, the big ones towards the bottom. We have the analytics collection database, which is connected to the content delivery environment, and the analytics reporting database, which is connected to the content management environment. And again, this is for scalability. In some environments, we've merged those two databases together. In general, the arrow tips, which probably aren't very visible, indicate the direction of information flow. Most of the lines are blue, which represent typical ADO.NET or in-memory and other standard methods for interacting with data in a database. But there are a couple of red lines that, again, may or may not show up, but those represent alternative database interaction technologies such as bulk copy and SQL Server integration services. So where we have a high volume of data that needs to go across the network quickly, we use those kind of technologies instead of doing just SQL statements. And when I say BCP, I don't mean the BCP command line utility, I mean operations that we can access in .NET, such as bulk insert and bulk copy. Each of the box components on this diagram supports horizontal scaling by adding additional instances, servers, or databases. So you can have multiple content management environments, and that's typical in customers that have multiple geographical locations and they want a server that's close to their user base. And you can also have multiple content delivery environments for similar reasons, but a different audience. Within each environment, you can load balance. So you can load balance, since 6.3, you can load balance CMS out of the box, and you have always been able to load balance the content delivery environment. You can also publish to multiple publishing target databases to support those different content delivery environments. But the biggest change from the overview perspective on this diagram is the separation of the analytics tracking, the database where we collect behavior information from the content delivery environment, from the reporting database, which we use for populating reports in the content management environment. So that's probably one of the major requests that we've had about OMS historically, and so we've implemented that with this release. And again, this shows some optional report elements, such as keeping those databases separate. And when we do have separate collection and reporting databases, we use SQL Server integration services to synchronize those databases. We use bulk copy when we're writing the data from the content delivery environment to the collection database, and I'll go into a little bit more detail on that. So that's really about as much time as I want to spend on this diagram. I'm next going to go through what some of these boxes are to say what happens in the content management and content delivery environment. This slide lists CEP functions implemented in the content management environment. So in that environment, CMS users define events and campaigns. They define their content and apply attributes to their content, such as profiles. They define multivariate tests and personalization rules, engagement plans, which function like workflow but for users, and other related data elements, all the stuff that they do in the master database. And CEP, or at least CMS, publishes those changes from the master database to one or more target databases. You'll see the content management environment manages subscriptions to analytics reports. So when we want to configure that a user is going to receive a report, we'll do that activity in the content management environment. But we'll see that the content delivery environment is actually responsible for delivering those reports. So content management is really for management, and content delivery is really for doing the work. We have a new engagement automation designer application, which lets you define these engagement plans through a browser-based user interface instead of like the tree that we would use for workflow currently. There's also an application called Engagement Automation Supervisor, which you can use to monitor users' progress through the engagement plans, to add visitors to states, and to change the states associated with visitors, so to reassign visitors from one state to another manually. Another aspect that we provide in the content management environment is the Engagement Automation Monitor, which is basically similar to the supervisor, except it's read-only. So if I just want to see what's happening on the system and not interact with that data, or if I have users that should only have read-only access to the system, they would use the monitor rather than the supervisor. This slide lists the functions implemented in the content delivery environment. So instances in the content delivery environment invoke rendering rules and multivariate tests, record attributes such as the browser used and GeoIP data, as well as visitor behavior such as the pages that the user viewed and the events that those pages kicked off. And that gets written to the analytics collection database. If instances in the content delivery environment use GeoIP information, such as for personalization, you would configure the content delivery environment to perform those GeoIP lookups. But if you only use GeoIP data for reporting, which I would say is unusual, you would instead configure the content management environment to perform the lookups. It's just like almost anything in Sitecore, you can configure exactly which instances in which environments perform each specific function. Instances in the content delivery environment are typically responsible for functions including visitor classification, traffic type designation, and subscription notification, so actually sending the emails to your customers. Content delivery instances process automations, so it's actually the content, while you define your engagement plans in the content management environment, the content delivery environment is what actually pushes the users through those processes. For example, to move a user, if a user might trigger a campaign, they might come back to your site, and that might trigger them to move from one state in the engagement plan to another. The next slide that I'm about to show shows the database schema for the digital marketing system, and hence the customer engagement platform. Again, this diagram will be available after the presentation, but may not be exactly accurate. And some of the reasons behind the new schema, or the changes to the schema, a lot of it was to simplify SQL queries and improve performance. So CEP will break some tables into multiple tables. Some of the tables that were in OMS 1 will now be 2 tables, but more commonly, 2 tables from OMS 1 will be implemented as a single table in CEP. And so those of you that have written SQL queries will definitely have to adjust those queries. CEP, for whatever reason, pluralizes certain table names that also appeared in OMS. So we used to have a page table, now we have a pages table, and we used to have a page event table, which is now page events. Probably the most important thing to remember is that CEP replaces the term session with the term visit, and replaces the term global session with the term visitor. And that helps to differentiate from ASP.NET sessions and avoids reusing the term session. So a visitor is basically a browser that comes to your website and can come on any number of visits. On each of those visits, they can request any number of pages, and each of those pages can result in a number of events that get reported to the analytics collection database. But not just events, it can also record GeoIP information, the referring websites, search keywords, and all the stuff that we're used to from OMS. So here's the database diagram. I realize this is pretty much illegible for almost everyone in the room, but it's here as a reference for anybody that downloads the PowerPoint after the presentation. One intention of the new database schema is to minimize the need to join more than 2 tables. So most joins involve the visits table, which is the big table that is in the middle of this diagram, and records in the visits table link to a variety of data in other tables. Most importantly, visitors, pages, and page events. So almost every concept that we describe relates directly to a table in the database. In addition to visits, visitors, pages, and page events, CEP includes tables containing information about profiles, tags, campaigns, notifications, tests, user agents, browsers, screen sizes, operating systems, GeoIP data, locations, visitor classifications, referring sites, traffic types, and search keywords. So that's basically what the different tables are, and almost all of them just link directly to the visits table. So that's all I have for the schema. Next, I'll present a new strategy for managing the customer engagement platform database interactions, implemented to optimize analytics collection performance. If you're familiar with the OMS 1 architecture, and actually I know that some people have mentioned this issue to me, we had a simple queue that we used to serialize database operations, which was to avoid overwhelming the database server. And the reason for that is that we think that when you've reached your capacity of your system, it's more important to serve traffic than to report what that traffic is actually doing. So this queue prevents you from overwhelming the server and lets you keep serving your published website when you've hit your limit in terms of what the machine can tolerate. CEP continues to queue the database operations in the same way, but takes advantage of a couple of technologies that allow multiple database operations to perform more like a single database operation. So specifically SQL Server integration services and bulk copy improve the performance for high volume transactions. This is done to minimize interactions with SQL Server. We manipulate the data in memory before we commit that data to the database, and we use the technologies like bulk copy and bulk insert when we can. This improves the scalability and performance and reduces the potential need to drop the visit data. The diagram that I'm going to show intentionally oversimplifies the implementation, and that's intentional because I want to get across this key concept that we're basically batching a number of operations into one transaction and then hitting the database with that instead of doing each of those in series. This is only one of several database optimizations in the CEP, but it is one of the most important architectural changes in the product line. So on the left, any number of web clients access a content delivery environment, which in turn writes visit information to the SQL Server on the far right. For each visit, Sitecore maintains what we call a visitor data set in the ASP.NET session until that session expires. So for performance, you probably want to use improc for that, but you could use SQL Server session management for managing that data as well. The visitor data set contains information about the visit, such as the keywords that brought the user to the site, the referring website, any page events that have been triggered by their current visit, and other attributes of the visit. CEP merges data from multiple visits into tables in memory, and then uses bulk copy or bulk insert operations to copy that data from memory to the database, again, minimizing SQL interaction. At the end of each page request, CEP copies change data from the visitor data set to a changes store, and then immediately transfers that data from the changes store to a change queue in memory, and that's where OMS 1 picks up, is that change queue. The change store and the change queue contain data collected from multiple visitors. Background processes periodically move data from the change queue to what's called a commit data set. And I'll mention some settings that you can use to control how frequently this happens or at what point it happens. Finally, a background process immediately attempts to use bulk copy or bulk insert to efficiently transfer the data from the commit data set to persistent storage. If bulk copy fails for some reason, and I don't have details on why that would happen, but apparently bulk copy can fail, then CEP falls back to using standard SQL statements. So again, this architecture really minimizes the number of database transactions, and the technologies that we use improve the performance of those transactions, which leads to improved efficiency, performance, and use of resources, which increases the system capacity. There's another performance feature in CEP, which is that we can load historical data about the user's prior visits into this visitor data set, and then that's managed in session so that if we have to access the same data again on the next page request, it's already available to us without having to do a SQL query or reload data. And as somebody mentioned, I can't remember exactly who, but Sitecore does not commit any data to SQL Server until it is sure that the user is not a robot. So we're not wasting database capacity by, and I mean in terms of how much write we can do, not how much storage we use, but we're not using either of those for robot data as we might have in the past. So in the past, you had to clean out the robot data after populating the database with it. So next, I'll mention some of the configuration settings, and this is really about as complex as CEP gets for most people from the architectural perspective. Is these three slides, the two diagrams, and then this information about the configuration settings. You don't need to remember these settings, but it might be important to remember that they're there. So obviously, you don't need to know the names of them, but if you ever run across some kind of need that could depend on these settings, it might be useful for you to have seen them. You can use the analytics.disable database setting with the digital marketing system enabled to collect visit data into the visitor data sets in session, but never write that data to the external database. So an example of that would be if I use GeoIP information for personalization in the content delivery environment, but I don't want to record that data to the database for whatever reason, I would set this setting to true. The analytics.automation.machine name setting is there to define which instance or instances in a group invoke the marketing automation logic. There's the analytics.perform lookup settings, which is not new, but I mention it here because previously we had recommended that customers do GeoIP lookups in the CMS environment, and because we found that GeoIP information was so frequently used, not for reporting, but for personalization in the content delivery environment, we now suggest that you do the lookups in the content delivery environment. So this setting just controls whether an instance performs GeoIP lookups. The analytics.trackerchanges.max rows setting limits the number of entries in the tracker object that maintains information about a visit. You can use this setting in conjunction with the following flush interval and sleep settings to configure flushing of track data to the database. The analytics.trackerchanges.flush interval setting defines the minimum interval for flushing data to the database, regardless of the analytics.max row setting. The first value reached will trigger CEP to move the data from the change queue to the commit data set. And the analytics.trackerchanges.sleep setting is the minimum time to wait before checking either the max rows or the flush interval settings to determine whether to flush the queue. Now that we've looked at the architecture, the database schema, and some of the implementation details, a few configuration settings, the next several slides introduce the various APIs. So this is the part that I think most people will be interested in, but I had to introduce some of those concepts in advance. Unless otherwise indicated, all the APIs that I described in this presentation are within the Sitecore.analytics namespace in the Sitecore.analytics assembly. So I'll just mention, because we've seen this issue in support so many times, when you add a reference to this assembly to your project, you need to set the copy local property to false, just so Visual Studio doesn't delete random DLLs from your bin folder. When you write data using CEP, it's important to use these APIs so that the data gets loaded into that visitor data set in memory. So you don't want to write directly to the analytics database. You should always use the APIs for your writes. And as I'll show later, you typically want to do reads through these APIs as well, because the visitor data set is going to cache that data, which is going to improve performance. So you automatically benefit performance by using these APIs as opposed to reading data directly from the database. And there may be cases where you still want to write SQL queries. If you know that performance needs improvement in one specific location, you can continue to write SQL queries directly against the database. And I would say that's for reads and not for writes. This slide lists the classes that you can use to access the fundamental customer engagement platform concepts of visitors, visits, pages, and page events. Understanding these terms and concepts is probably more important than remembering the concrete classes that are listed here. Engagement involves visitors who return to the site on any number of visits. On each visit, a visitor can access any number of pages, along with other associations such as search keywords and campaigns. Each page can trigger any number of page events, such as goal completions. And so a visit is basically the sequence of page requests and page events for a visitor. A visitor can return for any number of visits. You'll typically access those classes by accessing the Sitecore.analytics.tracker class, which is responsible for tracking each visitor. So you'll just access properties of that class, and it will give you the information that you need about them. So you don't really need to know the types of those other classes. The Sitecore.analytics.tracker class is similar to the Sitecore.analytics tracker class from OMS 1. It's another static class, just like the Sitecore.context class. So you don't have to construct this class or retrieve it from a provider. You just access the properties that you need. So it uses a pipeline just like HTTP request begin to populate this object, just as it does for the other static class. One of the key properties of this class is the current visit property, which represents the current visit. And that corresponds directly to a row in the analytics collection database, and the class that's used for that is the visitor dataset.visits row class. The current page property represents the current analytics page request. So we have the current visit and the current page. And it also corresponds to a data type that maps directly to a record in the database or a table in the database. Each of these has a data context property, and other classes, such as the class that represents visitors, also provides a data context. And so that's basically a property that exposes utility methods for loading information about that type of object. So one of the things I mentioned is that you can load partial or complete visit history for the user. And the way that we would load visit history into that data set in memory is to use the sitecore.analytics.tracker.load method. And that loads data about previous visits by the current visitor into the visitor dataset managed in the ASP.NET session. For performance and to minimize the historical data loaded into each tracker, you should construct what we call a visitor load options object, which we pass to the load method, and in that enable minimal options. So the object that we pass to the load method tells that method what data to load. Do I need just basic visitor data? Do I need their visit history? Do I need to know what pages and page events they trigger? So we'll tell it to load as little data as possible just to avoid accessing the data in the database and using more memory than we really need. So you can specify in that visitor load options object a range of visits to load. So if you want to load all of the visits for the user or the most recent 10 visits for the user, you can tell it exactly which visits to load. You can also specify which data to load. So you can tell it to load attributes, such as the search keywords that brought visits to the site, GUIP information from those visits, the pages involved in those visits, the events triggered by those pages, the user profile data from those visits, or there's other types of information that you can load as well. And so I'll show a code example that uses the sitecore.analytics.tracker.load method to retrieve only the keywords that brought the current user to the site on the current visit, or on one of the 10 most recent visits prior by that individual visitor. I'll also show an example that loops through subsets of the visits in the user's history, attempting to locate a specific event. So to see if they've ever registered for a campaign, for a conference or something like that. So I really hope these are readable for most of the people in the room. If not, you can get the PowerPoint afterwards. But you'll notice that the formatting is really inconsistent. The code lacks comments, asserts, error control, curly braces for single lines, and other aspects of self-documenting code. I really tried to fit as much code as possible as I could on these slides, and that's why it might not be the best quality of code. This example first checks the tracker.currentvisit property against null to confirm that tracking is active for the current visit. So that's kind of standard practice for anything that accesses CEP APIs. You want to confirm that tracking is active before you start invoking other APIs. It then uses the tracker.currentvisit.keywords property, which is going to contain the search keywords that brought the user to the website on this visit. If the current visit is not associated with keywords, it loads data from up to 10 prior visits, again using that visitor load options object. And notice the properties that we pass to that object. In this case, we say to start with the previous visit and load information about the most recent visits prior to that, up to a maximum of 10 visits. These visit load options also specify not to load unnecessary data, such as the pages that the visitor viewed, but only to load core data, including the search keywords. The code then iterates those visits in reverse order to locate the most recent visit associated with search keywords. So you can use this kind of pattern to iterate through the user's visits and access properties of those visits. Reports from customers and Sitecore's own experience with the OMS1 indicated that GUIP information was really the aspect of OMS most commonly used in content delivery environments. But GUIP lookups can take some time, and GUIP, it's not like you have a database with all the GUIP information in it. Every time a new IP address comes to the web server, Sitecore has to place a request against some external provider to get information about that IP address, and that process can take some time. So GUIP information is not always available when processing the first request for a new IP address. The customer engagement platform uses a background process to do those GUIP lookups, and you can run that again on any environments you want, and it's going to go out there and contact Maxmind or whatever provider you choose or implement to get that GUIP information. And one of the reasons for that is to avoid doing redundant lookups if you get requests from the same IP over and over again, because those services typically charge on a per use basis, per IP address, or per request. So the enhancement is that in the new CEP API to retrieve GeoIP information, you can specify a time span or a period of time to wait for that GeoIP lookup to complete. You don't want your user to notice that there's a performance delay, so you don't want to wait for that lookup to complete. You want to keep going with your processing if the GeoIP information is not available within a given period of time. So that method is the update GeoIP data method of the tracker.currentVisit object, and it returns true if GeoIP information is available for an IP address within the prescribed time limit. And Michael told me just a few minutes ago that there are other options, but this is the one that I expect customers will use most frequently. So this example passes a time span of 100 milliseconds to the tracker.currentVisit.update GeoIP data method. If it's not already available, this code waits up to 100 milliseconds for the background process to retrieve the GeoIP record for the IP address associated with the client requesting the page. If the GeoIP record is available, it then checks if the specific provider, in this case MaxMind, was able to determine GeoIP information for that address. We'll see later that you might sometimes want to spoof your IP address. So if you're testing on your local machine, your IP address shows up as 127.0.0.1 typically, and you'll want to override that with some other IP address. I'll show how that works. So you can actually get GeoIP information into your test environment as well. And then finally, if information is available for that IP address, it then checks for a business name associated with that IP address. So next I'll present some CEP APIs for working with analytics page events. Again, each page in the visit can trigger any number of events, including goals such as completing a form, downloading a file, or registering for a conference. You can use these APIs to evaluate events associated with pages in the visitor's current visit and their visit history, such as to determine if a user has ever achieved a specific goal. You can also use the API to associate page events with pages. So we'll see how all of that works in the next 3 slides. This example first checks that tracking is active, which is something that anything that uses CEP API should do before it continues. It then locates the event named register in the goals collection, which appears as an extension to the database class. So we're looking at the definition of the event named register, or the goal named register. For example, you might want to customize the presentation based on whether the user has registered for a conference. So to identify any registration event associated with the current visit, this example invokes a simple link to determine if any pages in the current visit are associated with that event. As I mentioned previously, you can use the tracker.load method to load visit history. Depending on whether visit history has been loaded for this visitor, the tracker object always contains data about the current visit, but may contain data about prior visits. So anytime I access these APIs, I need to differentiate between the current visit and prior visits. And that's why we have the query on the ID there. So continuing that example, after checking that tracking is active and that the current visit is not associated with the registration goal, this code loads the user's history in batches of 100 records and loops through those batches until it locates such an event. I showed this to one of the chief CEP engineers and they said it was a terrible anti-pattern. If you think about it, if I want to load somebody's history, it's probably more efficient to load all of the history in one database transaction than to go in batches. But I still think that there are cases where you would want to loop through. For instance, I might want to only go back to a certain period of time, or there might be other reasons why I want to go in batches of some number of records. So depending on how much history exists for a user, the batch size, and how much data you actually need, this could have better or worse performance than loading all of the history data at once. But you should generally avoid loading all the history data if you can avoid it. In some cases, again, it might be more efficient to write database queries directly against the database. But my goal here was to further demonstrate the principle of loading partial visit history. And so these are the APIs that you could use to do that. This code completes that example by associating the registration event with the current page. So first we checked, is this event associated with the current visit? Then we checked, is this associated with any of their prior visits? And we did that in batches of 100. And then finally we found no such events in their history, and so we're registering the event. And then if I ran the same code again, so the next page request, I wouldn't get to this point because the event would be associated with the current visit. So we've seen some of the APIs, and now I'm going to move on to some of the new pipelines that we have. And I'm going to start with the parse referrer pipeline. The parse referrer pipeline parses the referring website transmitted by the browser in HTTP headers to identify search engines and search terms associated with the current visit. So the customer engagement platform invokes the parse referrer pipeline on the first page request for each new visit. The parse refer pipeline contains a single parse generic search engine processor that identifies search engines that use query string parameters to indicate the search term. So when the browser goes to Google and does a search, Google passes a query string into itself in the subsequent URL, and we're basically looking at that search term and the host name. So we're looking at the query strings and the host names to identify which search engine and which search terms brought the user to the current site. So this is the default definition of the parse refer pipeline. The parse generic search engine processor is the only processor by default. This processor handles typical search engines that use query string parameters to specify search terms. So a Google search result page uses the query string Q to identify the search term. And the first entry in this configuration list with a host name that matches the current request will trigger CEP to record the corresponding query string value as the search term for the current visit. You'll notice that the host names are trimmed, and that's to better support search engines that operate in multiple geographies that have different top-level domains or suffixes on the host name. And you can add search engines to this configuration. Just add the common host name and the query string parameter that they use. For example, there's a variety of search engines in Japan that we don't use in the United States, and so in that kind of environment, we might want to add additional search engines to this list. But we'll also see that we can add our own processors to this configuration, to this pipeline. So if there's, let's say that there's a search engine that uses the path and the URL for the search term rather than using a query string parameter, you can implement a processor that does that. So that's what I'm about to show, a custom processor for the parse refer pipeline. And again, this is looking at the refer sent by the browser, the page that links to the current page on your website. So the page on the search engine, the search results page that links to your website. Internet search engines generally do not link to development, tests, and production content management environments. They typically only link to your production content delivery environment. So it can be a little bit tricky to simulate search engines in your test environment. There really are no search engines that link to your test environment. So I'm going to show how we can add a processor to this pipeline that spoofs as if the current request came from an external search engine. So this mimics the search engine results page, or to mimic a search engine results page, this processor, the set test refer processor in the parse refer pipeline overrides the refer specified by a browser. So processors in this pipeline accept an argument of type parse refer args, and to override the refer for the current request, I just need to set the URL refer property of that parse refer args argument. So this example processor sets the search term to a unique string, just a timestamp, just for example purposes, and uses the Google host name so that any request that triggers this processor will record Google in some unique search term as the search engine and search terms that brought the user to the site. In addition to configuring the default generic processor in the parse refer pipeline, you can implement your own processors in this pipeline. So the next example I'll show is, I call it the path parser pipeline processor, which is kind of a hard thing to say. But it demonstrates how to support search engines that use parts of the path in the URL as opposed to using query string parameters. So we'll see that if a parse refer pipeline processor identifies search keywords for the current visit, it passes that value to the get keywords method in the data context for the current visitor and assigns the result to the keywords property of the current visit. So if we identify a search, if the referrer contains the host name that we're expecting, which was passed to the processor as a parameter, it decodes the first step in the path and associates that as the search term with that host name as the search engine. So if I were to a URL such as /search term /options, instead of using query string parameters, this processor would record search term as the search term instead of looking for a query string parameter. One of the important things to note here is the use of the tracker.visitor.datacontext.getKeywords method. So we get the keywords out of the path and then we pass into this method. This gets a record in the database because we could have the same keywords coming to the website over and over again. Like CMS or Sitecore, those will bring people to our site over and over and over again. I don't want to make multiple database records. For storage and also for reporting, it's better to have one database record. So we get the database record associated with this search term, and then we apply that as the property. So moving on to another pipeline, the start tracking pipeline. This is the pipeline very much like HTTP request begin, which initializes the sitecore.analytics.tracker static class with information about the current visit. The start tracking pipeline also processes query string parameters that trigger page events and campaigns. Finally, it processes the tracking field in the context item, which defines events, campaigns, and profiles associated with the item. Along the way, the start tracking pipeline invokes a variety of other pipelines, such as create visit, which in turn invokes the parse refer pipeline, and that is the one we saw previously that associates search keywords with the current visit. So I mentioned that you might want to sometimes override the IP address that the web server sees as the client, and so that's what the example I'm going to show does. It overrides the IP address associated with the current visit with the public IP address of the Sitecore server. So again, GeoIP providers don't manage records for reserved addresses like 127.0.0.1, which you would see if you're accessing Sitecore on your local workstation. And for other reasons, there will be cases where you want to override the IP address. For example, a content delivery environment behind a firewall that sees a proxy's IP address instead of the actual referring or the actual client. So if this processor identifies specific values in the GeoIP property of the tracker.current visit, specifically 127.0.0.1 and 0.0.0.1, which we might sometimes see, it then passes, it looks up the public IP address of the Sitecore instance and passes that IP address to a method very similar to the one we just saw. Again, we don't want to record the same IP address multiple times, so we'll call a method that translates that IP address to a database record, and that's what we'll actually set as the property. So I think I'm running low on time here. So this code first checks that tracking is active, and for error conditions indicated in the GeoIP record, then if the visitor has either of the specified IP addresses, it calls webutil.executeWebPage, which is a handy little method that goes out and retrieves a web page and pulls that into a string for you, and then passes the IP address, which now contains the public IP address of the CMS server, and sets that as the GeoIP property. And again, just note the use of the visitor.datacontext.getGeoIP method, which we use to map an IP address to a record in the database. And again, that's efficient for storage, but it's also practical for reporting. So I'm just going to mention a couple of additional pipelines, which you can use, for example, to integrate with a customer relationship management system. Like any pipeline in Sitecore, you can add, remove, and replace processors in these pipelines to customize Sitecore however you want, to integrate with external systems or to kick off whatever custom logic you want when these events occur. The register page event pipeline invokes rules defined in an event definition item. So for example, the goals event definition item that I mentioned previously could define rules to invoke when that event is triggered. So we have a very similar thing for campaigns. Based on a campaign definition item in the context database, the trigger campaign pipeline processes tracking rules, changes the traffic type, invokes the rules engine to invoke additional rules, invokes marketing automation tasks associated with the campaign, and finally registers the campaign as a page event. In his session later today, which I would recommend attending for anybody in this audience, Kerry is going to talk about automation, and he'll describe the pipeline that we use for automating engagement. And it's pretty much open. If you go into the sitecore.analyst.config file, you can see how DMS affects the default pipelines that ship with Sitecore and the pipelines that it adds, as well as all the settings that it adds to the system. So this slide containing my contact information concludes my presentation, providing a technical overview of the customer engagement platform and its objectives, the new database schema and management strategy, some of the configuration settings, and a few new APIs and pipelines. As a result of these changes, we expect performance to be improved. Actually, testing has shown that we've greatly improved performance, capacity, and hence coverage. The APIs should be easier to use and more efficient for retrieving data. The GeoIP lookup feature we expect to be kind of a hit with developers because it lets you keep processing even if the GeoIP information is not available instead of waiting for it to become available. My contact information is up here, so you can email me for the slides now, or I think they'll be distributed at the end of the conference. And it'll include PDFs of the two diagrams, so you can get more detail about those. I hope you enjoyed the presentation. We'll use whatever time we have left for questions and answers. I'm just going to close with something that I heard at a Microsoft training facility once. There's no such thing as a dumb question. There's good questions, which are questions that I can answer. There's great questions, which are questions I can answer with a demonstration. And there are interesting questions, which are those to which I don't know the answer myself. So that's advance warning that I won't be able to answer everything that people ask, but I'm going to turn it over to Howie Bagley for questions and answers. He'll go around the audience, or he'll look on Twitter. And to see Howie.
I'm
There he
here
is.
in the back.
Howie's at the back of the room.
So if anybody has a question here, raise your hand. First question.
I've actually got a couple of them. Will the device that was used be stored in the visits table? And if not, is the visits table extensible to store items that might be interesting to us?
I'm sorry, I don't know the answer to that question off the top of my head. I was kind of prepared for a different question, which asks the difference between user agents and browsers. I don't know if there's any engineer in the room that could answer that question, but I'd be interested in why you would want that information. You could always determine it at runtime, but I kind of have a feeling it will be in there. We store a lot of information in the analytics database that I wouldn't necessarily expect, that we could calculate on the fly, so I don't want to answer definitively, but I would assume it's in there.
It isn't in the current version. Determining what targets the platform, what platforms to target in the future, being able to look back at the history of what devices actually accessed your site.
Right, so we do record the user agent, which is the actual user agent string transmitted by the browser, and then we also have a separate table where we record the browser, so how many visits are coming from Internet Explorer versus other browsers. So the browser client information is in there, but the specific Sitecore device used, triggered by that request, I'm not sure about.
Last time I looked at this, I had 650,000 unique user agents, so I didn't have an easy way of querying the database to find out how many of those were iPhone without putting together a really complex query, whereas when the device was detected, storing that would be useful.
Right, yeah, I can definitely see that. So, I'll try and remember to ask the engineers about that. And I do intend to blog about this presentation at some point, probably after Dreamcore Europe, and I'll try and answer that question in that blog.
One more quick question.
Lars up here might have the answer. Yep, so Lars says that we do store the device ID in the database, if that simplifies the query.
I noticed the event names were queried by name instead of a GUID. Did you run into problems with reuse of event names, like register, for example?
I don't know the answer to that one either, I'm sorry. I only look at the products before they ship, and I don't really get very much production experience with them. I actually would expect the same problem, but we would have heard about that in OMS 1 because it was the same, I think it was the same approach in OMS 1. So there is another way that I could look up an event, which is instead of passing the name of the event, I could pass the ID or the path of the event. So if I did have two goals named register, I could get at it a different way. There's a question at the front.
I just wanted to ask which versions of Sitecore is the DMS for?
Yeah, so the question is what versions of Sitecore does the DMS support? And the answer is only 6.5. So DMS, or what would have been OMS 2, requires CMS 6.5. A couple rows behind you.
Hi, is the database schema for the transactional database the same as for the analytics database?
So that's a good question. There are very minor differences, and it has to do primarily with automations, if I remember correctly. So going back to this diagram, you can see that there are just a couple of things in the reporting database that are not in the collection database. And it has to do with summary information. There's summary tables that improve the performance of some of those reports. There's a definitions table for things that are only in the content delivery environment and not accessible necessarily to the content management environment. And that's it. The rest is the same. I don't know how he is, but I see a question over here.
Is there any way you can mention the content of the visitor in DMS and explicit the visitor in
Right, so I think the question is there a relationship between the visitor in terms of the browser that came to Sitecore and what we see as known users, so the extranet database users? And the answer is, well, it's a little bit more complicated than that because we could have visitors that never came to the website. So if I take users from my CRM system and start putting them through engagement plans, I have no visitor data set for that record. I have no information about that visitor. I just have the user. So what we've done is we've added columns for extensibility that let you basically populate a column in our database for the visitor records that relates to a record in an external system or in our extranet database. But I don't know if it stores the extranet database user by default. I would assume that it does, but we need to be able to override it for customers that don't use that functionality.
So would it be possible to have a visitor refer to the browsers to provide access?
Yes. So, I mean, this is one of the first things I thought of, because I use different browsers all the time, and there's cases where I intentionally clear my cookies so that I get recognized as a new user and things like that. And I would say that there's no magic thing in Sitecore that will pull those two records together. If a user comes from their mobile phone and a browser on their laptop, then they're going to have two visitor records in Sitecore. And there is a function to merge those two visitors together so that they appear as one visitor, or you can tie them together if they're a known user by populating that username column. But we don't have any way to do that. There's a question up this way.
It seems like the DNS uses memory for a lot of storage, temporary storage. Is there a change to the minimum memory required?
That's a really good question. I would say probably not. I mean, these visitor data sets, while it stores a lot of information, it stores it very efficiently. And, oh, sorry, the question was, it sounds like CEP DMS stores a lot of information in memory, and does that increase the platform requirements for CEP versus previous version of Sitecore? And I haven't heard anything specific about that. But I would say that for one thing, this stuff is not necessarily stored in memory. You could store it in a SQL Server session instead of in memory. But I'm sorry, I can't answer the question. I know that when we add CM or OMS to a project, we do definitely increase the hardware requirements, but I don't know how much CEP DMS OMS 2.0 affects that limit. Is there a question here?
Just DNS supports lazy loading.
So does it support lazy loading? And man, I can't answer a single one of these questions.
Those are interesting questions, right?
Right, yeah, these are interesting questions. So if these pop up on Twitter, or if there's some way that I can follow up on these after the conference, I'll get in touch with engineering. My contact information was up there. I'll put it back up. This is my email address, so anybody here can contact me directly. And again, I do intend to blog about this presentation, so I'll just pile those questions up and try and get the answers and put them on the blog when it comes out. So please do email me your questions about CEP and DMS. We have 3 more minutes for questions. Oh, no, 1 minute.
What is the tracker from? It used to be in the memory pipeline. Is it earlier now?
So what invokes the start tracking pipeline, which is what starts populating the tracker object? And I'd have to look. I'm sorry, I just don't know the answer off the top of my head. Makes me feel like I don't really know what I'm talking about. There is a question over here.
Just thinking about the maintenance, out of the box, are there going to be any automated database maintenance routines that apply for the ready to run?
I know that we expect that customers will implement their own monitoring and maintenance plans for the databases, and we do also expect that those might be different for the collection and the reporting databases. So I would say that out of the box, nothing that I am aware of. The question was, are there any database management or maintenance stuff built into CEP by default? So we're out of time, I think. Really enjoyed talking to you guys today. Again, just want to appreciate the feedback. I mean, we do a lot of broadcast, and we don't always get a lot of feedback. So talking to you individually and hearing what you have to say about the product and the documentation and the company is really rewarding for the people here at Sitecore. So I really appreciate you coming to the conference and attending my presentation.